Hello students, the question says according to Master Foods, the company that manufactures M&Ms, 12% of peanut M&Ms are brown, 15% are yellow, 12% are red, 23% are blue, 23% are orange, and 15% are green. We want to answer the following questions. We want to compute the probability that a randomly selected peanut M&M is not orange. In this case, we want basically to find the probability that the selected peanut M&M is any other color but orange. So we can say this is the probability. This is 1 minus the probability of selecting an orange, which is basically the complement of selecting an orange. This is an O. So the complement of selecting an orange is basically not selecting an orange, and it is equal to 1 minus probability of selecting an orange. So this is equal to 1 minus the probability of selecting an orange is 23%, so 0.23, which is equal to 77% or 0.77. So the probability of selecting not orange is going to be 77%. In another way, you can find the probability by adding every other probability except for the orange. So the probability of not selecting an orange is the probability of selecting a brown color or yellow or red or blue or green. Since I'm saying or, we know we're adding these probabilities up, and we know because of the events here are mutually exclusive, it's just the addition of the probabilities without excluding all of these probabilities happening at the same time, because they can't happen at the same time. An orange M&M cannot be blue or green. If it's an orange, it cannot be any other color. So we can say that is the probability of brown, 12%, or selecting yellow, which is 12%, or selecting blue, which is 23%, or selecting green, which is 15%. That will give me 77% or 0.77. We want next to find the probability that a randomly selected peanut M&M is blue or green. So we want to find the probability of blue or green. We know the events here are mutually exclusive, meaning they can't happen at the same time. The peanut M&M cannot be blue and green at the same time. So the probability here is the probability of blue plus the probability of green. So that is equal to blue is 0.23 or 23% plus the probability of green 0.15 or 15%. The answer is going to be 0.38 or 38%. We want next to find the probability that 3 randomly selected peanut M&Ms are all yellow. That is, say the first is yellow, and the second is yellow, and the third is yellow. Since we have and, we know that we're going to use the multiplication rule. So that is the probability of the first one times the probability of the second one times the probability of the third one. And we're using this rule because we know the events are independent, because we have percentages in this case. So that is the probability of yellow is 15%, 0.15 times 0.15 times 0.15. And again, the events are independent here since we have percentages. We don't have the raw numbers. And since we're rounding to 3 decimals, we're going to say the answer is 0.003. The actual number was 0.003375, but since we're rounding to 3 decimals, that will be the answer. Next, if you randomly select 3 peanut M&Ms, compute the probability that none of them are red. That means the first one is not red, the second one is not red, and the third one is not red. The probability of selecting not red is basically the addition of all other probabilities except for the red color, and that will give me 12% plus 15% plus 23% plus 23% plus 15%. Or we could say 1 minus 0.12, which will give me 1 minus 0.12, that is the probability of selecting a non-red M&M. So this is the probability of selecting the first one. This is the probability of selecting the second one, not red. And this is the probability of selecting the third one. So this is equal to 0.88 times 0.88 times 0.88. Again, all of these events are independent. So it is just a multiplication of the probability. And the final answer is going to be, we're going to round it to 3 decimals. So this is going to give us 0.682. So that is the probability of selecting none of them is red. The first one is not red, the second one is not red, and the third one is not red. If you randomly select 3 peanuts, M&Ms, we want to compute the probability that at least one of them is red. So if you notice, none of them is red is the opposite of selecting at least one of them is red. So we could say the probability of selecting at least one of them is red is 1 minus the probability of selecting none of them is red, which is the complement of the event. So 1 minus the probability of selecting none of them is red is the complement of that event, and it is exactly selecting at least one of them is red, because the opposite of selecting none is red is selecting at least one is red. So to find that answer, you're going to say 1 minus 0.682, which is going to be equal to 0.319. So that is the probability of selecting at least one of them is red out of the 3. See how we used the complement to compute the last part. In this case, if you compute it any other way, it's going to be a dreadful process. If you try to build a tree diagram to figure out the answer, it's going to be a dreadful process to do. So it's best to use the complement method in this case. I hope this video helped you understand how to compute simple probabilities when we are given percentages, and I'll see you in a different one.